everyone. So the topic that we are starting with today is conic sections. As the name suggests, in this topic we will be seeing how on sectioning a conic in different ways we get different mathematical figures, which you have already done one of the chapters of this conic section, which is circle. The other three, which are parabola, ellipse and hyperbola, we will be studying now. But before we understand that how and why these parabola, ellipse and hyperbola are being studied, let us understand the importance of these three figures or these three conic sections in our day-to-day life. You all are familiar with the GPS system that we use in our day-to-day lives. That is a part of how a circle and a radical axis works. You have done radical axis in your circles chapter. The location of any place, the exact location of any place that you use using your GPS system is basically identified by satellites using the concept of circles. Also in the chapter of kinematics, you have done that when you throw a ball or when you throw any substance from a building or from anywhere, or when you play cricket, the motion that the ball takes is basically a parabolic motion. Okay, so we are familiar with these things in our day-to-day life. We are using these things in our day-to-day life. But what is the importance and how do we calculate all these things? That we will be dealing in this chapter. Even in your medical sciences, when you are taking these kidney stones, these are also used or these are also broken using the concept of ellipse or by creating elliptical tanks. So we are using all these concepts in our day-to-day life. So it is necessary for us to understand what parabola, ellipse, hyperbola are and what is the use of circles. So circles we have already dealt with. Now we will be dealing with parabola, ellipse and hyperbola. So starting with basically the basic of a conic section, first we will try to understand what a conic section is. A conic section, as the name implies, is a section cut off from a circular, not necessarily a right circular cone, by a plane in various ways. The shape of the section depends upon the position of the cutting plane. So the two things that are provided over here are a right circular cone or basically a cone and a cutting plane. The cone that they are saying is not necessarily a right circular cone. What do we understand by a right circular cone? Right circular cone means a cone whose height is perpendicular to its radius. Okay, so they are saying that the cone can be a right circular cone also, or it can be a normal cone also. And the second thing that they are giving you is a plane. So on the type of ways the plane is cutting a cone, you will get different structures. Consider a double right circular cone of semi-vertical angle alpha and let it cut by a plane inclined at an angle theta to the axis of the cone. We will get different sections or curves as follows. So now we will see how by cutting the cone by a plane, how we will get different structures. The first structure that we can see here in the figure 1 is a pair of line. Now see, the line that is perpendicular to the radius is known as the axis of the cone. This point in the middle is known as the vertex of the cone. Now in this case we are considering right circular cones only. Right circular cones means that the height of the cone is perpendicular to the radius of the cone. In this case, as you can see that this line and this line are intersecting at what point? They are intersecting at the point V. So they are basically pair of lines which are passing through a common point of intersection, and that common point of intersection is V. So when the plane, you see a right circular cone, then the plane if is intersecting at this point, at this part is known as the generator of the cone. This part is known as the generator of the cone, and if the plane is cutting through the generator, then you get the pair of straight lines which are intersecting at what point? They are intersecting at the vertex of the right circular cone. Similarly, in the figure 2, you can see that if the plane is cutting parallel to this radius, if they are cutting parallel to this circle that you can see on the bottom, then you get a circle over here. The cross section that you will receive when the plane cuts parallel to the circle, the base circle, then in that case you get the conic section as a circle. So in the first case we saw a pair of straight lines, on the second case we saw a circle. So the same right circular cone, depending upon how a plane is cutting it, you are getting two different figures. Now the first two cases that we discussed were those of a pair of straight line and a circle. Now let us come to the figure number 3. if the angle of inclination between the axis of the right circular cone and the plane that we are using for cross section is less than 90 degrees, or in radians you can say pi by 2. So if your theta is less than pi by 2, where theta is the angle between the axis and the plane that is being used, then in that case the cross section received is that of an ellipse, that you can very clearly see in the figure 3. So the angle between the axis and this is theta, which is lesser than pi by 2, and when it is inclined at that angle, then the cross section that you are receiving over here is that of an ellipse. Okay, so when the theta or the angle is lesser than pi by 2, then the cross section received will be that of an ellipse, which you can see in figure 3. Coming to the figure 4, in this case theta is equal to alpha, which is the angle that you have seen in the first slide. Now see, in this case, if you can see the cross section that is being received by this plane is this. This cross section is what? This cross section is known as a parabola. Similarly, if the cross section is like this, that means a plane is intersecting perpendicularly. If this is the case, then in that case you get a hyperbola, one over here and the other over here. It basically looks like a parabola, but it is on both the sides of the right circular cone. So since it is on both the sides of the right circular cone, we call it a hyperbola. So the shape of the parabola, you can say it is like this, and the shape of the hyperbola is basically on both the sides. So this becomes hyperbola, and when it is only on one of the sides, then we call it a parabola. So these are the figures that you get when you cut a right circular cone by a plane. Depending upon the change of angle, you get different cross sections, and those cross sections have been defined as straight lines, parabola, circle, ellipse and hyperbola.